All right, guys, welcome back. Just please confirm you can see my screen and you can also hear my voice.
Yes, I can.
Thank you. All right, so we are looking at the determinant of a matrix. This is again new terms and new words and things that we are talking about, and it's part of matrices and you will hear it a lot. So we also have to talk about them, okay? Matrices and determinants, right? So within this lesson, we need to know a determinant of a square matrix, properties of determinants, applications of determinants, area of a triangle, solution of systems of linear equations. This is also Cramer's rule. So this is part and parcel of the final lessons, but before we go to that final part of the lessons, we also need to understand a little bit what it means by the determinant of a matrix. We also spoke about the inverse of a matrix. We spoke about the adjoint of a matrix. We spoke about the transpose of a matrix. There's a lot of terms to understand and look at. And all those terms, you have to know what it is at some point in time. So determinants of a matrix, basically, if we look at a matrix which has one element, okay, then we are looking at this matrix has a dimension of 1 by 1, right? That's the one element that we have inside. We said that the elements is most, if you multiply the row by the column, you will get how many elements are inside of that matrix. That's basically what we are talking about. So in here, we say the square matrix of order 1. Order 1 is just, that's one element. So then if we look at the determinant of this matrix A, then we will say that, okay, this is just A with the determinant. We now talk about this lines over here. Now, in the vectors, that is now where the problem comes in also to differentiate. With vectors, when we had vector A like this, then we said that this is basically the magnitude of the vector, where we had like the root of x squared plus y squared, right? That is what we basically looked at. All right. Now with the matrices is slightly different. It's not the same. Okay. So this is also why we are explaining it separately. All right. But the same principle we have for these two lines. These two lines is still talking about the absolute value. Okay. So an absolute value is just all numbers that are greater than 0, or it means that the answer must be positive. We normally want to get a positive number if we have those two brackets over there. All right, we don't want negative numbers, more or less. And so we can either get a 0 or a positive number in one way or another. And sometimes we get negative numbers as well, but we will see how that works for us. All right. So let's now say that was a single element in a matrix. So if we have a square matrix, and you can see that this is row 1, column 1, column 2, row 2, column 1, row 2, column 2. This is now a square matrix of order 2, right? And then if we want to get the determinant of the matrix, we follow a simple rule. We basically just like a cross multiplication, and then we do a subtraction over there as well. All right. So we will be putting in some examples over here. I just want to quickly mention here that you will see that this is whatever this element is over here, you multiply it with that element over there. Okay. And that takes the first position, right? Then we minus it with the second element, first element in row 2 by the first element in column 2. And then that is what we have over there. And then we subtract the 2, okay? And preferably using this, we will be able to get the determinant of a matrix. So here we have an example that we can evaluate the determinant of the matrix. So we have these elements over here. Okay. So the solution for this, we said we will cross multiply and then subtract. So I have 4 times 5, which is the 4. Right, we multiply it with the 5 over here, that is here, and then we take the 2 and we multiply it with the -3, and this minus is what we have to put in between the 2. So 2 times -3, that's what we will minus. So 4 times 5 is 20, and 2 times -3 is -6. So you will see that we have a bracket minus minus. So that minus minus changes into a positive, and then we will get a positive answer over there. So the determinant of this matrix, please note this is a matrix as well. And the determinant of the matrix, because we did not give it a name yet, so we just said solution, it's just an example. So the determinant of this matrix will be therefore 26. So you can see that the determinant is looking for a whole number for the matrix itself, all right? And that is basically like getting the value in terms of size of the matrix, the distance of all the elements that are in there, what we have. All right. So this one is finding a determinant of a 3 by 3 matrix or matrix in that order. So you will see that determinants are normally just get determinants from square matrices, 3 by 3, 2 by 2, and so forth. So for a 3 by 3 matrix we have to change it more or less into a 2 by 2 matrix. And I did not do a very good job in explaining this. But what we do is we take the first element here, all right? We put it outside over there, okay? And once we've taken the first element over there, we then cancel the row in which that element is in and the column in which that element is in. And then from there on, we take the remaining ones that are not in that row or in that column of that first element. And that is what we will now become like a matrix on its own. So this is like a scalar. Sorry, the scalar now is the first element, and then the matrix is the remaining elements that are not in that row or that column of that element that we have taken. Okay, so that is how we do it over here, and then we get this part done. All right, and for the next one, we do the same thing again. We can take the second element in that row, which is this one over here, and we will put it outside. Okay, and the first one will be minus because we are trying to minus it out. The rule is you will always get that the first sign will be minus, the next one will be positive, and the next one will be minus, positive if we continue forever. So it always starts with minus, then add, then minus, then add. That's how we do determinants. So again, we do that. We take that one out, and after we take that one out, we cancel the row. Okay, so the row, those are the elements in the row, and we cancel the column, right? And then we take what elements are left. So this is left, and this is also left. So this two together, we make it one matrix, and we bring it into that side. So you will see A21 is there, A21 is there, A31 is there, A31 is there, A23, A23, A33, A33. And that is what we have over there. So we are basically changing this 3 by 3 into a 2 by 2 type of matrix so that we can get a determinant faster. So that one is done. Then we, since we have started with the rows, we continue with the third one. That is the one we take out over on that side. And then we follow the same principle. We cancel the rows or the columns where that element is coming from. And now we take the remaining values that are not in that row or the column of that matrix. And you will see that is what we have over there. 2, 1, 3, 1, 2, 1, 3, 1, 2, 2, 3, 2, 2, 2, 3, 2. All right. So we just deconstructed this 3 by 3 matrix and made it a 2 by 2 matrix. Okay. And then once we have now that, we have a minus first and then a plus. And then now we can now expand this by multiplying the scalar quantity with everything inside. And once we have the scalar quantity of that one, we get the determinant of this 2 by 2 by doing that cross multiplication and minus for each one. This one you multiply in cross, and then at the end we will now simplify all of those things again. So this is just the algebra way or algebra version of what we have. And after we do all of the things like that, we get our answer. So this is like a example using numbers, what we have over here. So just remember again, we start by always taking the first element, which is the 2, and then we will put it outside as a scalar, and then we cancel the rows, which is this, and we cancel the columns, which is that, and then we take these elements that are not in the red, which is this one over here, and we make that the matrix over here. Okay, so that's where we get it from. And then for the next one, we do the same thing. If we take the 3 outside, and remember, you have to start with a minus, then a plus, then a minus if the matrix is too big. So we first do the minus now, minus the 3, which is the outside one. Okay, and then we take cancel the row, sorry, not that ones. Cancel the row, and then we cancel the column, and then we take what remains, the 7 minus 3, it's there, the minus 2 and 1, it's there. And then we do that again for the minus 5. So remember, it's minus plus minus plus. So we are now at a plus, that's why you see the plus here. And we take the minus 5 outside, and then we cancel the columns and the rows, and then we take this part in there as well. And once you are here, then we do that determinant thing that we've learned before. We multiply these two minus the answer we get from that one. And obviously multiplied by everything is multiplied by 2 inside here as well. And that is what we get. And we do the same for this one. We do the same for this one after we multiply the scalar quantity first. Okay, so that is now how we will get to these answers over here. Let me just show you how we got to this answer over here. So this will be 1 times 1, which is basically 1, right? Minus, and then we have here 4 times minus 2, and 4 times minus 2 is minus 8. So I have minus 8, 1 minus bracket minus 8. So this bracket minus 8 becomes a positive 8, and that's what we have there. And this is multiplied by 2, and that's where the 2 over here has just been kept outside of the bracket. We do the same thing for the other ones inside there. That is just basically the cross multiplication that I've told you about. And then since these are all numbers, I think after this point, once you get to this point, it's just going to give you a straight answer like this as well. So in this case, we have a negative answer for the determinant, and that is what we have over here. Now, this example that I give you guys over here is a 3 by 3 square matrix. For grade 11, according to our syllabus, you will not be doing a 3 by 3 matrix. You will only be doing a 2 by 2 matrix. So we will give you a matrix like this only, and then you just have to do that cross multiplication thing and subtract. Okay, so you don't need to produce or break down the big matrix like this in that way. However, next year you will be given a 3 by 3 matrix, and then they will ask you to do the determinant. So here we are explaining the 3 by 3, but basically we are just reducing it to 2 by 2, which is what you have to understand at this year. Okay, next year you will get these matrices, and then you will be doing those ones. That is basically what we have. We are not looking at cofactors now. This is also just extra things, but we will look at them again in the next year to come. Properties of determinants. The value of a determinant remains unchanged if its rows and columns are interchanged. Okay, so even if you changed or if you transpose the matrix, remember we talked about we have two different matrices, and now we are talking about, we have matrix A and we are talking about matrix A transposed. Remember I said that's the prime that we are talking about, where you have your rows which turns into columns. Okay, your rows which turns into columns, and your rows which turns into columns. Okay, so even if we change the matrix transposed and we are asked to find the determinant of that matrix, it will still produce the same answer. So determinant is a very unique special calculation that gives us the same answer all the time. If any two rows or columns of the determinants are interchanged, then the value of the determinant is changed by a minus sign. And that is just basically the minus sign that we have over here. We'll just add a negative sign. Instead of us doing the minus plus minus plus minus plus, okay, for the transposed matrix, it's going to be plus minus plus minus. Okay, that's the only thing that is changing. If you see the answers are slightly different. Okay, and properties continue. If all the elements of a row or column is multiplied by a non-zero number k, then the value of the new determinant is k times the value of the original determinant. And that is just basically showing why we did not first, when we had like something like this, where we had the 1, the 4, and the -2. It just says, why did we not just first multiply the 2 in with everything first and then get the determinant? It's just explaining that even if you don't multiply it in first, and you first find the determinant and then multiply the 2, it will still give you the same answer. Okay, that's just the rule here. And that is why we did not do it in the beginning. Okay, so it's just using the same examples that we have. Each element of any row or column consists of 2 or more terms. Okay, this is now just saying that if there's more terms in there, then the determinant can be expressed as a sum of 2 or more determinants. And this is now just trying to get those terms out. Okay, this is for 3x3 matrices. You will learn this next year at university, or you doing AS level. That is what you will be learning. And we don't need to focus on that. Okay, if any of the determinants are identical, then its value is 0. So if the value is 0, then we know this is a singular matrix, and that is what we defined in the beginning. Each element of a row or column of a determinant is 0, then the value is 0. If the rows, anything in the rows are zeros, then we will always be ending up with zeros, because we are basically multiplying, right? This will be this multiplied by whatever.
Stop that met jou nonsense.
Okay. Marshally, I don't know. Somebody is stressing you out at home. Okay. So that is basically it for determinants. Yeah, this is basically the signs that we were talking about. It's the plus, minus, and that's how we ended up with those plus and minuses, and the minus and the plus. And this is for 2x2, and this is for 3x3. So this is where I got that plus, minus, and minus plus from. Okay, and you will see this is for your 2x2, and this is for your 3x3. Okay, so it just adds another sign after each one of this one that we have there. This is for determinants of a matrix. Okay, okay, I will not go through the 3x3's examples. I will find another example for 2x2 for you guys. And this is just more examples, solutions, examples, and differences. Okay, so I just want to go quickly to the exercise. Let me just quickly see here. So I think I will stop there because that is basically what we wanted to explain how we got to this answers over here. So we have an idea where this number came from. We took this, all right, cancel the row, cancel this, then you cross multiply this two, you minus them, you will get 3 times 3 is 9, and then minus 3 times minus 3, which is minus bracket minus 9, which will be a positive 9. And that is how we got that answer over there, right? And we are just explaining now singular and non-singular matrix. So if we ask you, determine if the matrix is singular or non-singular, then we have to basically find the determinant of the matrix, okay? So a non-singular matrix is one example over here. If we do the same thing, we have 1, 1, 1, and we have a minus plus, we get that negative 9 is not equal to 0, so this becomes non-singular matrix, okay? Here we can use algebra to say that if this is a singular matrix, that means the determinant must be 0. So if we have x multiplied by whatever, we can basically try to use algebra to solve for x. And now we talk about the inverse of a matrix, okay? And I am sure that the inverse of a matrix is supposed to be the next lesson for tomorrow. So I will stop there. I just want to talk about identity of a matrix and the inverse of a matrix. So you have these two words, which is again confusing. Do I have text? Yes. So we have something we call a inverse, okay, which is the one there. And then we have another one called identity. And you will see that because these two words are both having the letter I in the beginning, sometimes in some textbooks, they say for inverse, they will say find I. For identity, they will say find I. So you also have to be very careful which I is it that you want to look for, which I are we looking for. So identity matrix is just basically a matrix which has ones along the diagonals, something like this. So we have 1, 0, 0, 1. This is what we call an identity matrix. If we find the determinant of this matrix, we will know most this multiplied by this. So it will be 1 times 1 minus 0 times 0. And you will get 1 times 1 is 1 minus 0 is just 1. So it's called identity because it returns a 1 for the determinant. And you would have noticed that we spoke about that over here, where we looked at identity matrices over here. This is the ones we are referring to, okay? So this one also gives us a 1 in the 3 by 3. But for you guys, we will be dealing with 2 by 2s. And that is why we have this identity matrix over here, okay? So I for identity and not I for inverse, right? That is basically what I was explaining. And as we continue from there on, you will see we are talking about this I and not this I. So that is another confusing part, which I just wanted to mention. And you have to be very careful also when we are doing our calculations regarding the I, all right? So the inverse of a matrix has different parts. Again, it's another problematic calculation where we had to look at the determinant of a matrix, the adjoint of a matrix, and all those things of a matrix. So this is why I'm stopping here, because if I continue any further, I will confuse you. And then I don't want to confuse you now. Let's first go to the confusion about the multiplication of the matrix. Let's first finish that confusion. And once we are done with that confusion, we will be able to to come to the next step and see if we can do that next step again. Okay, so this is basically what we want you to achieve today: multiply a matrix by a matrix, and that is it for now. But remember determinants. Tomorrow I will explain again a determinant, how we get it again, because we need that for the inverse of a matrix. And the inverse of a matrix is not the transpose of a matrix, but it has to do with transposing, it has to do with determinants, and it has to do with identity. And those are very challenging things that we have to do. So we save that for tomorrow, and then we will have questions on that tomorrow. I think that is it from my side. Is there any questions from your side before we end the session for today? Any questions? So I will post this up on Google Classroom as well. Please do attempt to find out how we can solve this, or if you can solve it. And if you can solve it, then we can move on to the next step. Otherwise, it will be problematic. And for those who did not do the first one, please do the first one as well, because you will notice a slight difference between the first one and the second one. And if you don't do any of these ones, when we go to the determinant and the inverse of a matrix, it becomes even more confusing. So this is why I say every lesson has an activity, and you have to do that activity for that lesson, or else you will be lost. Like seriously, you will be lost. Imagine where we started off with vectors, and now we are doing these things, and then from adding a matrix, it looks simple. Then we go to multiplying a matrix, which is not simple. From multiplying a matrix, we go to the inverse and determinant of a matrix, and then everything just goes blank. So I feel sorry for you guys. The new curriculum is no joke, and everything is very difficult, but they expect you guys to do it. They say you must, and it's hard work. All right. So as I said, for Loida, I will mark your thing, and then we will see how it goes on. If there is no other questions, we can call it a day. Please note, I am posting only old videos because those ones are already online. I haven't been into town yet. So tomorrow is Tuesday. Tuesday, I will be going to town. So I will upload some of the lessons we already did tomorrow. And that way you can also catch up with those ones, the newer versions of the lessons that we already did. And I hope that will also help revising. Right, so please be prepared for the test on Friday. And then I think after Friday, we will have a discussion if we should continue next week again, because we have been told the examination timetable is set, it's up. And when the school opens up in August, we will be basically scrambling. All the teachers, other subjects will be scrambling to get you to do something to prepare you for your exam. And it's a lot of difficult subjects for everything. And teachers will steal you from other subjects. You will not get time. They will throw everything on you to complete their syllabuses. And yeah, your life is very difficult at the moment. So I know this, trust me, I know it's not going to be easy for you guys, but what you can get online now is important also to reduce your workload later on. So when you guys come back from mathematics at school, I will just be doing revision and where they're struggling things. And I will refer to everybody and say, go check the videos, it's up there. I'm not going to be doing any of this lessons again. So please invite the other people to come to class. We still have until Friday to take the test to see if they understand the topic or not. And then maybe next week we can do revision on what we have covered online. And then when school opens, we only have 2 topics to cover, which will be probability, statistics and probability. I think that's the only two topics we will need to cover. Yeah, and that will be it. Yeah, then we have finished also the second book. Then that will be it from my side. So probability and statistics is another problem again. It's difficult. Everything is difficult, guys, but it's doable. It may be difficult because it's hard work, but it's doable. All right. So that's it from my side. Thank you guys for coming and enjoy the rest of your day. Please do the homework for tomorrow so that you are at least on the same page with me. Sharp. Yeah. Thanks, Jay. I'm gonna end this session.